Good day, viewers. I welcome you all to this mathematics presentation. So in this presentation, I want us to answer this question right here. So this is a question coming from matrices. So here we are given matrix A, which is a 3 by 3 matrix. We have question A, find the determinant of matrix A. Question B, find the cofactors of matrix B. C, transpose cofactors of matrix A. So I'm going to start with the so here we have started with the question A here, finding the determinant of matrix A. So we need to find the determinant of this matrix. So I'm going to write our matrix. We have matrix A, which is equal to, we have 2, 1, 4, 1, 3, 3, 3, 1, 1. So this is a 3 by 3 matrix. We need to find the determinant of this matrix A. So to find the determinant of matrix A, there are two methods that we can use. Okay, so we are going to say determinant of matrix A is equal to, now the method that I'm going to use, I'll use the signs. Okay, I'm use the signs. So we have these signs, plus, minus, plus. We also have minus, plus, minus, again plus, minus, plus. So if I choose to use the first row, I'm going to go with these signs. So I'll use the first row where I'll go with the plus, minus, plus. Okay, if I use the first row there, what is going to happen is that I'll be covering the entire row, okay, and the entire column. Then I'll also use a 2 here. That is the method that I'm going to use. So first thing, you are going to write a 2 like this. Then we do this. So here on 2, we are going to cover the entire row where 2 is, and we are going to cover the entire column. So the entire column is right here. So we are remaining with 3, 1, 3, 1. That is what I'm going to write here. So we write 3, 1, 3, 1. Okay. Remember, the first sign, it's a plus, so there's no need to put a plus here. The second sign here, it's a 1, so it's a negative, so you write a negative and a 1, which is right here. Again, you do the same like this. So you're going to cover the entire row, and you're going to cover the entire column like this. So you can see we are remaining with 1, 1, 4, 1. We come to the third element, which is a 3 right here. So what sign is it having? It's a plus. So you write plus 3. We do the same right here. So we are going to cover the entire row, and we are going to cover the entire column. You can see what you are remaining with. 1, 3, 4, 3. So you write 1, 3, 4, 3. Okay. So after doing this, then we can write determinant of matrix A is equal to, you write a 2 here. So this is a 2 by 2 matrix. We are now going to find the determinant of each of these 2 by 2 matrices that we have come up with. So we know how we find the determinant of a 2 by 2 matrix. We get the product of the major diagonal, then minus the product of the minor diagonal. So the major diagonal is 3 and a 1. So 3 times 1 gives us a 3. Minus 3 times 1 gives us a 3. Minus 1. Again here, the major diagonal 1 times 1, it's a 1. Minus 4 times 1, it's a 4. Then plus 3. 1 times 3, you get a 3. Minus 4 times 3, you get a 12. After doing this, just write 2. 3 minus 3 is a 0, minus 1, 1 minus 4, it's a negative 3, plus 3, 3 minus 12, this gives us a negative 9. Then after doing this, 2 times 0, it's a 0, negative times negative, it's a positive, 1 times 3, it's a 3. Then here, there is a positive here and a negative here. So say positive times negative, it's a negative. 3 times 9, you get a 27. So from here, we can now write our final answer, which is the determinant of matrix A. 0 plus 3, it's a 3. 3 minus 27, this will give us a negative 24. So this is the determinant of matrix what? A. Let us now proceed to question B. So now we have come to question B, where we need to find the cofactors of matrix A. So this is matrix A. How do we find the cofactors of matrix A? To find the cofactors of matrix A, you must take note of the signs. Remember, when finding the determinant, I introduced some signs that we should take note of. So we have the plus, minus, plus. We also have the minus, plus, minus. We also have plus, minus, plus. These signs, we should not forget them. We are going to use them when finding the cofactor of matrix what? Matrix A. So to find the cofactor of matrix A, what you are going to do is, we are going to draw a bigger, or you are going to come up with a bigger what? Matrix, like this one. Okay. When you come up with this bigger matrix, you have seen we have how many entries here? There are 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we must come up with the square, 9 square matrices. Okay, so this one is for these two, like this. Okay, then again here, should have 3 of them. This is very important. Take note. The last one. This is the last one. Okay. All right. So after coming up with this, then what are you going to do? You need to come up with elements that you are going to put inside here. So those elements, where are you going to get them? We will be starting with the first column here. Okay. So when I start with the first column, I'm going to cover the entire row and the entire column. That is what we are going to do. So we are going to cover this one, okay? Then we are also going to cover this one. Now this time around, we'll just be picking these entries here. So 3, 1, 3, 1. That's what we are going to pick. And we write here. So we have 3, 1, 3, 1. Okay. Then we are done. We come to the second one here, where there is a 1. We'll cover the entire row, okay? Then we cover the entire column, as you can see. What are we going to remain with? 1, 3, 3, 1. So you write here 1, 3, 3, 1. Okay, we are done. We come to the next one. We do the same, which is the 4 here. So we are going to cover the entire row, and we are going to cover the entire column like this. You remain with 1, 3, 3, 1. I hope it's clear here. So we'll cover this one. You have seen. You remain with 1, 3, okay, then 3, 1. So we are done for the first column. We now move on to the second one. So the second column is this one right here. So we'll do the same. We are going to cover everything here. We'll cover the entire row like this. Then we'll cover the entire column. So we remain with 1, 4, 1, 1. That is what we are going to write here. 1, 4, then 1, 1. We come to these 3 right here. You do the same. So you can see that we are just doing one and the same thing. When you cover the entire row here and you cover the entire column here, you can see what you are remaining with. There is a 2, a 3, a 4, and a 1. Okay? So you write here, you remain with a 2, a 3, a 4, and a 1. Then we come to this 3 down here. We cover, when we cover the entire row like this, and we cover the entire column, which is this one, where we have 3, 1 and 3. You remain with what? 2, 1, 3, 1. I'm sure you are able to see here. So you remain with 2, 1, 3, 1 when you cover here. That's what you are going to remain with. So we are done here. We come to the last column. So we'll do the same. We cover this entire row and we cover this entire column. We are remaining with 1, 3, 4, 3, which is 1, 3, 4, 3. Okay. So we now come to the other element here, which is a 1. Okay, so here if we block the entire column where 1 is, and we block the entire row where 1 is, you can see this one here. What are we remaining with? 2, 1, 4, 3. So here we are going to write, so you write 2, 1, 4, 3. Then we come to the last one, which is this one right here. Again, if you block like this, where it is, you have seen, we are remaining with 2, 1, 1, 3. So we write there 2, 1, 1, 3. So you write here 2, 1, 1, 3. Then from here we can continue. We are done, so we can continue. Now look here, I did give you these signs. So plus 1, 2, 3, plus, negative, plus. So plus, negative, plus. Again, negative, plus, negative, plus, negative, plus. So just put the negatives there. So these negatives are going to be multiplied with whatever determinant that you are going to get. So what you are going to do now is you're going to write equal to. So we are going to do this now. We find the determinant for each of the matrices here. So these are 2 by 2 matrices. So 3 times 1, that's how we find the determinant of a matrix. We get the product of the major diagonal minus the product of the trailing diagonal. So 3 times 1, this gives us a 3, minus 3 times this one, again gives us a 3. Okay, we come here, there is a negative here, so put a negative, open bracket. 1 times 1, it's a 1, minus 4 times 1, it's a 4, we close. We come to this one right here, 1 times 3, we'll get a 3, minus 4 times 3, we'll get a 12. So we can close like this. We come to this element right here, there is a negative here, so negative in bracket, 1 times 1, we get a 1, minus 3 times 3, we get a 9. We come here, 2 times 1, we get a 2, minus 4 times 3, we get a 12. We come to this other element, there is a minus here, so you have to be careful with the signs, okay? 2 times 6, sorry, times 3, it's a 6, minus 4 times 1, it's a 4. We close. We come here, 1 times 1, it's a 1, minus 3 times 3, it's a 9. There is a minus here, there is a minus here, so we put a minus in brackets. 2 times 1, it's a 2, minus 1 times 3, it's a 3. We are done. We come here, 2 times 3, it's a 6, minus 1 times 1, it's a 1. So you can see we are done here. Alright, so after coming up with this, we are now going to say cofactor of matrix A is equal to, so we can just try to simplify them. This gives us 3 minus 3, it's a 0. Then here we have negative 1. 1 minus 4, it's a negative 3. 3 minus 12, this is a negative 9. We come here, there is a negative here. Then 1 minus 9, it's a negative what? 8. 2 minus 12, this gives us a what? A negative 10. We write a negative here, 6 minus 4, it's a 2. So we are going to have a 2 in brackets there. 1 minus 9, this will give us a negative 8. There is a minus here. 2 minus 3, it's a negative 1 in brackets. 6 minus 1, 6, take away 1, okay? This will give us a what? A 5. Then from here, we can try to simplify. So the cofactor of matrix A will be equal to 0, negative, negative. So we are going to get positive 8. Then we write negative 8 here. Negative, negative, we get positive 3, negative 10, negative, negative, we get a 1 here. Then here we have negative 2, so negative 9, negative 2, right here, and then we have a 5. Okay, then we have a 5 here. So this is the cofactor of matrix what? Matrix A. Now, after finding this cofactor of matrix A, we come to our question C, where they said we should find the transpose of the cofactor of matrix A. So, how can we find the transpose of the cofactor of matrix A? So, for this one, since the cofactor of matrix A is this one, we just need to transpose. The rows will become the columns. So, row 1, row 2, row 3. It will be written like this. So this row 1 to become a column, to write 0, 3, negative 9. Here 8, negative 10 and a negative 2. You write 8, negative 10 and a negative 2. This one also become a column. It will be negative 8, 1 and a 5. So this is the transpose of the cofactor of matrix what? A. So this is our answer. So thank you so much, everybody. We've come to the end of our presentation. This has been your presenter, Mr. Mlenga. Bye-bye.